Building real-time machine learning models in Fintech usually hits a wall at the infrastructure layer. To train a fraud detection system or risk engine, teams historically export highly sensitive financial data out of secure vaults into external computing environments. That data movement creates immediate security vulnerabilities and processing latency. This animated diagram illustrates Snowflake's approach to data gravity through Snowpark Container Services, or SPCS. Instead of moving the data to the compute layer, SPCS brings the compute to the data. By dropping the application directly inside the governed data vault, you execute code in the same environment where the records live. To execute this in a production environment, we will build a 3-step technical program manager execution plan. We are going to deploy a Python-based real-time fraud detection system entirely inside Snowflake, focusing on these 3 empty slots: the container registry, the deployment model, and governance. Reversing the traditional data-to-app flow removes the security gaps inherent in cross-platform setups. When data stays within the Snowflake perimeter, you reduce the attack surface and eliminate the points of failure common in external data pipelines. Step 1 of the execution plan requires getting the developer's application code into the secure perimeter. We have to ingest the local Docker containers into the Snowflake environment without exposing the process to third-party tools. This diagram shows ingestion. A developer executes a standard Docker push command, routing the container directly into your Snowflake account, bypassing external registries. Teams retain their exact continuous integration pipelines and existing Docker commands, avoiding the friction of new workflows. Locking the container images inside Snowflake's boundary from the very first upload severs the connection to external staging servers. This removes a significant entry point for potential supply chain threats in financial applications. We move to step 2 of the execution plan. With the fraud detection system inside the perimeter, we must define its operational pattern and allocate the necessary computing resources. This blueprint shows execution options. For a fraud API, we select the service model. Highlighted with a continuous loop, it provides always-on execution. We attach this to a dedicated GPU pool, isolating workloads so the API never starves during spikes. Consider a different workload. If you need to process a nightly compliance report across 10 million rows, and you want the compute to shut down immediately after to save costs, which operational pattern should you use? You would select the job service model. It is built specifically for finite, batch processing tasks. It executes the workload and then automatically terminates upon completion. Precisely mapping the deployment model to the workload constraints, continuous for APIs, finite for batch processing, maintains strict cost controls while meeting the performance requirements of financial operations. The final step in the execution plan addresses the requirements of Fintech security, establishing the boundary and meeting compliance standards. This illustrates native security. Executing inside Snowflake, the container automatically inherits your role-based access control system. By repelling read external requests and linking directly to internal data, you eliminate the overhead of maintaining cross-platform identity and access management roles. Governed data stays strictly within the vault, never traversing an external network. This unified security perimeter provides a simplified compliance path for financial institutions, as all container operations remain within the existing audit boundary. The 3-step execution plan is now complete. We have successfully architected a real-time system inside the data perimeter. This diagram shows the complete architecture in action. By tracing the flow from a native Docker push through the integrated registry into a GPU-powered service model and locking it entirely under an RBAC shield, you eliminate the operational overhead of managing disparate container orchestration platforms. For technical program managers, memory retention of this architecture comes down to 3 tactical advantages: data gravity, unified security, and flexible models. Consolidating your execution environment within the data platform changes your focus. Instead of managing complex infrastructure bridges between platforms, you can focus on delivering secure, real-time financial applications.